Good day, everyone. Thanks for attending my talk. Unlocking developer productivity and best practices to release faster. This talk is more about empowering developers to deliver high-quality code with confidence. How many of you are developers here? Managers? Okay, fortunately. Have you ever seen this in your teams? Okay, have you ever, fortunately or unfortunately, have a production-graded outage due to a bug that you have actually introduced? Okay, I've done many times, so. The manager would ask who has actually introduced the bug? And the developer would say that, hey, it works on my machine. I don't know, okay? But let me check who has actually introduced the commit or introduced the bug. Okay, a brief introduction of myself. I'm Mohan Rao Chukka. I'm a senior software engineer R&D. I work for the platform engineering team at JFrog India. Passionate about open source and loves playing table tennis. The agenda of my talk and how an ideal development environment would look like, the challenges that on a day-to-day basis how developers would face. I would probably like to cover the end-to-end testing with a tool called Cuttle and a live demo, and the best practices that we have learned in our journey, and probably a quick takeaway what we can do probably going forward. An ideal development environment would look like a single-click automation. Say that a new developer joins your team or onboards, he should be able to set up the environment in a day or two or within the same day and start contributing on the same day. And probably the more important is develop and test locally. Most of in our companies that we have seen, they write code on some Windows or on Mac, and they test it on Linux or some other containers that we have it in production in. And ideally, it should be same as production environment, as clearly same as production environment. Okay, so the challenge that most developers have is, how can I actually push the code that is actually production ready and see that entire tests that I've run, local test or unit test or end-to-end test, but most of the developers face an issue where they can't run those integration or end-to-end test locally. The main reason is the test environments are very hard to set up, and they don't have quick automation around. Say, for example, I might be running our end-to-end test in a Jenkins CI/CD server, and setting up that Jenkins server locally is a pain, right? So, which would mean most of the bugs would get through instead of running them, testing it locally. Most of these bugs would occur at a stage where these runs at a CI/CD server. I would probably cover how that the entire flow would look like, and which would mean time wasting in fixing those issues at a later point. So the idea around here is to make sure that you test locally and to have a same environment that is very similar to production, okay? But why does most developers think that, hey, local testing may not be sufficient? Okay, it says some of the environments, like production-grade environments, are time-consuming to set it up, required some CI/CD expertise or infrastructure management around setting up those things, and say that some of the laptops, I don't think the current laptops that we have that restriction of running those entire suite of tests. Maybe the dependencies that we have with databases and other things. And more importantly, the time to set up the entire environment. So unless you have some automation around this, I don't think this would work out, okay? So we at JFrog were evaluating how can we solve this end-to-end testing that developers can test locally, okay? So take an example. I, as a developer, work on a feature branch, okay? Based on the requirement, create a new feature branch, write some unit test, okay? Write some unit test, do a commit, and then push it to a Git repository for a review, okay? What happens generally is these end-to-end tests are configured to run on a CI/CD system or on a Git repository. And these are run at a remote CI/CD server, generally, like Jenkins or any pipelines that you have. So what happens is, when you run these tests on a remote CI/CD server, when the tests fail, you need to probably get back to the root cause of the issue, checking at the logs, okay, of the remote CI/CD server, and then try to understand it and try to push it again, understand the fix and try to push. This round trip actually continues. So we at JFrog, hey, how can we actually, is there any tool that can help us to leverage, rather than running these end-to-end tests on a remote CI/CD server, and run these tests locally, okay? So this is the depiction of what I said was, developer writes the code, writes some unit test, raises a pull request, okay? Then the remote CI/CD server runs those tests. If something fails, this round trip actually continues. It's a lot of wastage of time, I would believe, okay, rather than fixing them locally, okay? So we at JFrog were evaluating a couple of tools. How can we leverage, run these local end-to-end tests, okay? So what I mean by that is, instead of running those tests on a remote, these tests would run entirely locally. So what you would do is, if you find an issue, you would just commit those changes locally or an amend, and then run those tests locally, okay? Repeat it until you verify that everything works, okay? So this actually saves a lot of time in terms of pushing it and running it on a remote CI/CD server, okay? So instead of remote end-to-end test, use locally to test, locally commit to a feature branch. So what I was referring to here is, bring these remote CI/CD tests to your local, okay? So we were evaluating a couple of tools, and we found a tool called Cuttle, Kubernetes test tool. This was part of the Kudo Builders project, CNCF project, where they tried to test the operators using this tool called Cuttle, okay, which is quite popular. This is primarily a toolkit for writing tests for mainly operators, but it can be used for any Kubernetes objects, okay? YAML-based, you don't need to learn a new language for this. And it also creates a Kubernetes environment, like namespaces and other things, so that you can run it. So the infrastructure part is also taken care, okay? I would like to run through the demo at a later point, okay? So how to get started, okay? If you are using a Mac, you can use brew, install Cuttle CLI would help. This is an older way of doing it, but you can install brew, install Cuttle CLI would. And if you are using a Linux, you can use a kubectl crew install Cuttle. And if you are a Go developer, and if you want to integrate this Cuttle into your API test, you can also use this Go GitHub Kudo Builder Cuttle, okay? So my talk and my presentation would focus on the command line aspects of Cuttle today, and not on the Go side of it, okay? So what Cuttle is for? Cuttle is for an application admin who wants to create a new Kubernetes environment and test your Kubernetes resources. Say that I'm a developer. I would like to test on different multiple versions of Kubernetes whether my application is supported or not, okay? So what you can do is, you can configure whatever the Kubernetes version that you want to deploy, and Cuttle will test it for you. And if you want to test operators or any Kubernetes objects without writing any Go code, say you are a Java developer or a Python developer, you can still use Cuttle, okay, without integrating into the Go code, okay? So Cuttle has three main configurations. One is the test suite. Test suite is a collection of different steps of test steps. So it's a CRD, okay? You can see an API version Cuttle dev v1 beta 1, and the kind is test suite. You can mention kind start as false, which would mean you can use an existing Kubernetes cluster that you have and run those tests as well. And if you set kind is equals to true, in my demo it would be set as true, so that it runs locally, okay? So the entire Kubernetes cluster, kind actually depends on, Cuttle depends on kind as a local Kubernetes cluster. You can use Minikube as well, but Cuttle inbuilt has kind as a local Kubernetes cluster. So you can specify which directories that you want to test against, okay? And this is the prerequisite where I want to add a Helm repository and test my Helm charts, for example. And more importantly, it has a timeout. Say that you want your test to be timed out after 300 seconds. If the test continues and crosses around 300 seconds, it would actually fail, okay? As I said, test suite has a collection of test steps. Test step is also another CRD as part of the CUTL, where you can define the commands. So if you are using an existing tools for your integration testing or anything, you can actually use CUTL so that it creates a namespace and runs those tests. So you can actually import those tests directly into this, okay? So I'm running a simple Artifactory install kind of a thing. So more importantly, once you install, as part of the test step, you want to do an assertion, okay? So CUTL does a declarative assertion of what it actually builds on. Say, for example, if you want to test an API that you have recently developed, a REST API. So what you can do is, as part of the test step, you can actually invoke that, start the application, and do a curl call, okay, or an API call. Then in the assertion step, you can probably get the response of the curl response and see it matches with the expected response or not, okay? In my demo, I would be simply installing an application and to see if the application come up and do an assertion based on the test step we have. Okay, so this is the complete structure of my demo, where I would have an end-to-end test. I have two tests, install and scale, and there is a CUTL test.yaml, that is the suite structure that we have. I would probably want to first show you the code that I have. Is it visible to you guys? Okay. So this is the CUTL test.yaml. This is the suite file. This is a random name that you can give, and you can see start kind as true. So what I'm doing is I have a Rancher desktop installed on my system. So I would like to use kind as the local Docker desktop, okay, or local Docker, and run my Kubernetes things, okay. And since I don't want to actually download all these images, what I've done is I've downloaded all these images upfront, okay, and asking kind to load these images so that to save time, okay. Since I know that these are all the container images that I use for my tests, so I've pre-downloaded them into my Rancher desktop and loading them here so that the tests run much faster. Okay, and I'm using a test directory. This is the root directory that we have. And say, for example, if you like to run these tests more frequently and to cache these images locally as well, you can use kind node as true, where the subsequent run, the first time it would run, fetch those images. Subsequent run, it would actually be much faster since it caches the containers or container images, okay? So I have two tests. What I'm trying to deploy is simple Artifactory OSS open source version of Artifactory. And I would like to do an assertion whether Artifactory comes up, okay? There is two ways of deploying Artifactory, with one being a split mode and a non-split mode. I would show you what it is. And I have this configuration file. So let me quickly run through a live demo that I have. Okay. So what you can do is you can brew install CUTL CLI. Okay, I would probably want to skip this because I've already installed it. I just wanted to show you guys. Okay, so kubectl CUTL test, simple one-line command that would actually run all these tests and give you a report as well. So you can format the report in a JSON or an XML format, and you can probably plug into your CI/CD system so that it can show you what test has run, what tests have actually failed. Okay. So what it does is it starts a kind local cluster, okay, on the Rancher desktop that we have, and this is a temporary folder. So I would like to, give me a second, while it runs. Okay, Okay, let me do an export of this kubeconfig file into this specific. So I'm getting the context of it so that I can use a tool called K9's open source tool to view the kind cluster. Okay, you can see here we have the default kind cluster with all the default namespaces that we have. So what it actually does is, so let me go back, switch the context once. So it tries to install Artifactory in one namespace, since the namespace is actually being parameterized. So it would create a random namespace, install your application, and in the second test also it would install Artifactory OSs, and we can do an assertion based on that. So what it need to ideally do is create two namespaces, run those tests, and do an assertion, declarative assertion on top of it. So you can see it is actually executing the Cuttle suit file, where it is trying to get the, adding the JFrog chart repository, open source charts repository. This is very similar to existing tools that you have used. You can just plug it into Cuttle so that your infrastructure part of creating namespaces and other things are taken care, and you can run those tests. So you can see here, it gives us a clear output that it has, okay. So it says it has 3 tests because it has another directory, but you can ignore that. So it is creating 2 namespaces, okay. So you can see in the bottom side, it has created 2 namespaces, okay, and trying to install Artifactory in that, okay. Let me get into that namespaces to see what it is actually running through. Since I've preloaded all these images, the install step is quite fast. You can use K9s to view the Artifactory logs while it gets installed. Once Artifactory installs, then the assertion step would automatically trigger to verify that the replica counts are actually same, okay, to verify the exact replicas that we have mentioned. Say, for example, I want to start your application with 3 replicas. So you can change your assertion part to 3 replicas so that the install part is taken care. As I said, you can actually integrate with APIs as well, so that the request response is also being matched using an assertion, okay? So so this is one instance of Artifactory where the internal microservices are actually being exposed as split to containers. And there is another Artifactory where this is a single monolithic application of Artifactory of single application where all the services are packaged in one sense. So I would like to test both of them to verify. You can see here, it is already been terminated. So which would mean it has already done a validation and also destroying the namespaces as well. So the infrastructure, say for example, if you are a Go developer or a Java developer, what you need to do to write an end-to-end test, you need to spin up a namespace first, okay? Deploy your application, okay? Then do a cleanup using the Java code or Python code or things. So what it brings is, the infrastructure part is taken care. You can just integrate this Cuttle into your end-to-end test framework and run those tests in different namespaces. And good thing about Cuttle is it supports parallel running of tests. So you can run 8 parallel tests based on the CPUs that you have. So you can mention how many tests that you can run parallelly. Earlier we were using chart testing tool for testing our CI, which would have taken around 1 hour to test all those things. With using Cuttle, we have actually gone down from 1 hour to probably less than 10 minutes running those tests parallelly, okay? So you can see here, Cuttle has run those tests, 2 tests, which is, okay, ignore this. This is more like the chart that I've downloaded. Since we don't have a proper internet connection over here, I pre-downloaded the Artifactory OSS chart so that it runs from my local rather than fetching it from a Helm repository, okay? So these are 2 tests that I've ran. It has been successful. Then what I would do is, I would probably do my changes and commit locally and raise a PR so that I'm confident that I've run those end-to-end tests locally, and it also makes sure that my CI would also work with the changes that I've done, okay? Okay, so I would probably want to cover the best practices that we have achieved. Okay, I would probably finish it in the next 5 minutes if we have another 5 minutes for Q&A, and we can probably have an early lunch too, okay? So what we thought was developers was not running those end-to-end tests locally because setup was complex, bugs were caught late. The solution, we were able to integrate, simplify, using automation to have a local environment, very much similar to what we deploy to production, because we are deploying it onto a Kubernetes cluster. And we are using a kind cluster, which is an exact replica of Kubernetes cluster on your local, deploying it, testing it out, and then pushing the code changes to a Git repository, okay? What was the outcome? Few bugs reported, faster and confident releases, which had made our developers' life happy. And the next important thing that what we discovered was, how many of you as a developers deploy to production? I mean, do you get an opportunity to deploy your code into production, or are there any specific SRE teams that do the deployments? You do the deployments? Cool, okay. So what we have learned from the last few years was taking the ownership of right from design to deployment, which actually solves the problem of running and maintaining it in production, okay? So why it actually matters is, for example, I being as a developer know the service architecture and the architecture and how to deploy it and how to run into the issues. Sometimes what would happen is I develop an application and leave the operations team or an SRE to deploy. They may not be knowing what feature is going into that release, right? So it's very difficult. So we at JFrog followed a you run it, you build it philosophy, where developers would eventually deploy it to production as well, okay? In our SaaS, okay? Which would mean better testing, and also we have some monitoring infrastructure so that we run those tests and monitoring, and the entire ownership is taken by the developers here. And the benefits that we have seen is reduce the production bugs and a faster resolution, because sometimes what would happen is an SRE would detect a bug at a later point when he's trying to deploy. If a developer does the deployment, it's much faster, and he's trying to correlate what changes that the code went in, so that he's trying to replicate and fix it locally as well. And it has given our developers end-to-end visibility, how an application from design to development can go within a span of 2 weeks, within a sprint time, okay? More importantly, as I mentioned, test locally, okay, is the mantra. I've shown you in the demo, single command, kubectl cutl test. You can integrate the same command in your CI flows so that it runs exactly the same, which actually reduces our broken builds or failed builds in the CI pipelines, aligns with local testing with production CI checks. And the last best practice that I would like to say is, being a developer, many would think that, hey, let there be a Jira, from a top-down approach, create some automation around that. As a developer, you can still do some modifications in your code, okay? That makes your life happier, okay? For example, you don't need to have something like some tools that you don't know. What you can do is write a simple make file, collate all those things, run those make file, right? Make end-to-end test. That way, developers can run those tests with a single command, and would also efficiently run those tests locally. So that's the reason I said DYU, do it yourself, rather than waiting for somebody to tell you that do this automation, okay? Okay, so finally, what the lessons that we have learned having local testing using Cuttle was, before the bugs were skipped, frequent bugs in production due to the skipped local tests because we did not have an ability to run them locally, slower releases, and most importantly, frustrated developers managing the complex setups that we had, okay? So after consuming the lessons learned, we were able to reduce production bugs by 80%. We were able to release much faster so that developers test it locally. And as I said, simplified production like local testing that we have. And also You run it, you build it. Developers own the quality, reducing the production issues. Okay, so as a takeaway item, what you can do by attending this talk is, if you are developing a new app, containerize it so that it runs on any environment without any issues consistently. Automate testing, write script, end-to-end test, use make files to have single line execution. Embrace, you build it, you run it, take ownership of the production behavior, test locally, and more importantly, share knowledge with your teammates so that they would also like to run these tests locally. The main takeaways that I have, simplify local testing, automate everything, own the life cycle, you run it, you build it, test early, test often, no CI expertise needed, you don't need to learn Jenkins or anything, just one tool that would actually cover you to probably do the development and testing end-to-end. What it has resulted is a quality code and a fewer bugs and a faster delivery. These are the references that I have. I would probably share the presentation with the organizers already, so you can have these references as well. Any questions? Happy to take them. Sure. Can we get a mic?
First of all, thank you for this talk. So one question what I have is, running these end-to-end tests locally, do you think that this is scalable in terms of if we have dependent services that would be coming up, and also if there is a need for data in those end-to-end tests? So how do you manage with the Cuttle?
Okay, good question. So we at JFrog, most of our teams are using it, and scaling, which would mean, say, you might have a dependency with the other service. So what you would do is, rather than taking a released versions, you would take it from a milestone versions and do a testing around those things. Say, for example, I have a chart that might be dependent on 6 services, okay? The only service that is going into a change in a patch fix needs to be tested. So what you would do is, take a milestone version of that, plug it into your local thing, run those tests, and do that. The second question was, sorry?
If there was a data requirement, so basically to run those end-to-end test cases, if you want to have some storage, and based on that, whatever is there, we want to run an end-to-end test. So typically that's what happens.
Yeah, what you can do is you can preload some of the configuration using some scripts, okay? Have the data loaded and run those test things, which is not an exact scenario for this talk. It can be for anything. Preloading the data would be sufficient, I guess.
Okay, thank you so much.
Thanks.
Okay, in the interest of time, I think we'll wrap things up there. Thank you, Ram. That was a very insightful talk. And it's an ideal that we'll all be working towards. There's a small token of our appreciation. We'll break for lunch now. Talks will resume in the same venue around 1:50 to 2 p.m. Do tag us on social media, take photographs, and spread the word about KCD Bangalore. The hashtag is KCDBLR25. And yeah, hope all of you enjoy the lunch. Do network and then meet a couple of new people. Don't just keep talking to the people you came with.